Hello, in this lecture we will find the area of the green shape in three different ways. In the drawing we have a circle. We know that the radius of this circle equals to 5 units, and we have this green shape, angle ACB equals to 60 degrees. We also know that AC is tangent to the circle at point A, and CB is also tangent to the circle at point B, and we want to find out the area of the green shape. So I will start with the first method. Okay, first of all we will define the center of the circle as point O. Then we will join points A and O by a straight line. Actually, AO is the radius of the circle that equals to 5 units, because of the fact that it starts, line segment AO starts from the center of the circle and ends at point A, that is a point on the circle itself. Therefore AO is the radius of this circle that equals to 5 units according to what is given us in the question. We will also connect together points O and B by a straight line. Actually, OB is also the radius of this circle that equals to 5 units for the same reason, because line segment OB starts from the center of the circle and ends at point B, that is a point on the circle itself. Therefore OB is the radius of this circle. Okay, and we have a rule about if we have tangent to the circle and radius, they are perpendicular to each other. So actually the rule states that in this circle, if you draw tangent to this circle at point X, and we have the radius, this is the radius, so the radius is perpendicular to the tangent. This angle equals to 90 degrees. So I will write down the rule. The rule states that a tangent to the circle is perpendicular to the radius drawn to its tangency. So actually tangent Bx is tangent to the circle at point X, and we have the radius of this circle that is drawn to the point of tangency. This radius actually touches the point of tangency, that is point X. Therefore, the radius is perpendicular to this tangent Bx, that is to say this angle equals to 90 degrees. Okay, so according to the rule, angle OBC will be equal to 90 degrees. And also angle OAC will also be equal to 90 degrees because the radius is perpendicular to the tangent. Okay. And what is the value of angle BOA? We have a rule that states that the sum of the angles inside the quadrilateral equals to 360 degrees. The sum of the angles inside a quadrilateral is equal to 360 degrees. So actually, according to the sum of the angles in a quadrilateral equals to 360 degrees. So according to this rule, angle AOB, this angle plus 90 degrees plus 90 degrees plus angle PCA that equals to 60 degrees. In total, the sum of those four angles must be equal to 360 degrees according to this rule. So we will get that angle AOB plus 90 degrees plus 90 degrees is 180 degrees. 180 degrees plus 60 degrees is 240 degrees. It equals to 360 degrees. So here we will subtract 240 degrees from this equality, and we will get that the size of angle AOB equals to 360 degrees minus 240 degrees is 120 degrees. So we found out that the size of angle AOB is 120 degrees. Okay. In the actually, we also know that AC equals to BC. AC equals to BC. So those two sides are equal to each other. So they are equal to each other according to two tangents theorem. Actually, two tangents theorem states that if from external point of this circle, let's define it as point P. Point P is the common external point. From this external point, we will draw two tangents to this circle. We call to the touching point between the circle and the tangent point A, and then from point P we draw second tangent to this circle. We will call to the touching point between the tangent to the circle point B. According to two tangents theorem, when from external point, from a common external point of a circle, that is to say point P, you draw two tangents to a circle, then the lengths of those two tangents are equal to each other, that is to say AP equals to BP. Okay? So I will write down the two tangents theorem. So two tangents theorem states that the lengths of two tangents from a common external point to a circle are equal. So two tangents theorem states that the length of two tangents from a common external point to a circle are equal. So if you draw two tangents from a common external point to a circle, then the lengths of two tangents of those two tangents are equal to each other, that is to say AP equals to BP. So, okay, so according to this rule, we have from a common external point, point C, we draw two tangents to this circle, tangent AC and tangent BC, and according to this rule, the lengths of those two tangents are equal to each other, that is to say AC equals to BC. Okay, so in the next step we will join together points C and O by a straight line. And we will focus on triangles AOC and triangle BOC. Okay, in triangle AOC and triangle BOC. Okay, we will focus on those two triangles. AO is equals to BO. Both of those two line segments are the radiuses of the circle, so therefore they are equal to each other, but they both equal to 5 units. So AO in triangle AOC equals to BO in triangle BOC. AO equals to BO equals to R, that equals to 5 units. Okay, AO equals to BO equals to R, that equals to 5 units. And also AC equals to BC according to two tangents theorem. AC equals to BC according to two tangents theorem. Okay, AC equals to BC according to two tangents theorem. AC equals to BC. And OC is a common side. It belongs both to triangle AOC, and OC also belongs to triangle BOC. So OC equals to OC. It is actually a common side. It belongs to both triangles. Okay, so we actually proved that all the sides of triangle AOC are congruent to all the sides of triangle BOC. Therefore, we proved that triangle AOC is congruent to triangle BOC. Okay, triangle AOC is congruent to triangle BOC according to side rule. Actually, side rule states that if you prove that all the sides of one triangle congruent to all the sides of the other triangle, then those two triangles congruent to each other according to side rule. Okay? So, from the fact that those two triangles congruent to each other, we can derive that angle OCA equals to angle OCB. Angle OCA equals to angle OCB. And this is according to the rule that corresponding angles in congruent triangles are equal to each other. Okay? corresponding angles in congruent triangles are equal to each other. Okay, so those two angles are equal to each other. So if we define one of those angles as x, if angle OCA, this angle equals to x, then angle OCB will be also equal to x. And the sum of those two angles will be equal to x plus x. That is to say, to 2x. So the sum of those two angles is 2x. And we know that the sum of those two angles must be equal to 60 degrees. Okay, so we have the equality that 2x equals to 60 degrees. We will divide this equality by 2, and we will get that x equals to 30 degrees. So x equals to 30 degrees, angle OCB equals to 30 degrees, and angle OCB will be also equal to 30 degrees. Okay, so we will repeat on the same process on those two angles. If we define angle AOC as y, then angle BOC will be also equal to y, because those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. Those two triangles congruent to each other. Therefore, the corresponding angles must be also equal to each other. So, if this angle is y, this angle also must be equal to y. So we know that y plus y equals to 180 degrees. That is to say 2y equals to 180 degrees. And if we divide this equality by 2, we will get that y equals to 60 degrees. So y equals to 60 degrees. So triangle AOC is a right triangle because this angle equals to 90 degrees, angle OAC equals to 90 degrees. Therefore, tangents 30 degrees equals to AO over AC. Again, in the right triangle, triangle ACO, angles 30 degrees equals to AO over AC. But what is the size of AO? AO equals to 5 units over AC. The value of tangents 30 degrees is 1 over root 3. So we'll substitute tangents 30 degrees by 1 over root 3 equals to 5 over AC. Here we will multiply this equality by AC, and then we will multiply it again by root 3, and we will get that AC equals to 5 times root 3. Okay, AC equals to 5 times root 3. AC equals to 5 times root 3. So the value of AC is 5 times root 3. Actually, after we found out the value of AC, we can easily find the area of triangle ACO. The area of any triangle, and especially the area of triangle ACO, that is the sign for area. So this means the area of triangle ACO equals to the base of the triangle times the height to the base over 2. Okay, the area of triangle BCO equals to the base of triangle BCO times the height to the base over 2. So the base is AO. And the height to the base is AC over 2. Okay, so AO equals to 5. AC equals to 5 times root 3 over 2. So in total, 5 times 5 is 25 times root 3 over 2. Okay? So the area of triangle ACO equals to 25 times root 3 over 2. Okay, the area of triangle ACO equals to 25 times root 3 over 2. But because of the fact that triangle ACO can go into triangle BCO, the area of those two triangles must be equal to each other. So, for that reason, we will get that the area of quadrilateral ABCO equals to 2 times the area of triangle ACO, because those two areas are equal to each other. Again, the area of quadrilateral ABCO equals to 2 times the area of triangle ACO. We have already found out that the area of triangle ACO equals to 25 times root 3 over 2. Okay, so the area of quadrilateral ABCO equals to 2 times 25 times root 3 over 2. So 2 over 2 is 1, so we get that the area of triangle, the area of quadrilateral ABCO equals to 25 times root 3 units. Okay, the area of quadrilateral ABCO equals to 25 times root 3 units. Okay, and what is the area of sector AOB? What is the area of sector AOB? So the area of sector AOB equals to the area of the circle, that is pi times r squared, times the angle between AO and OB, that is 120 degrees, over 360 degrees. Okay, so the area of sector AOB equals to pi times r squared, that is the area of the circle, times the angle between AO and CO, that is 120 degrees, over 360 degrees. Okay, we know that r equals to 5, so r squared is 5 squared. So it is pi times 5 squared is 25, and 120 degrees over 360 degrees is 1 over 3. So we found out that the area of sector AOB equals to 25 pi over 3. Again, the area of sector AOB equals to 25 pi over 3. Okay, what is the area of the green shape? The area of the green shape, you can see it from the drawing. The area of the green shape equals to the area of quadrilateral ABCO minus the area of sector ABO. Okay, again the area of the green shape equals to the area of quadrilateral ABCO minus the area of sector ABO. Again, the area of the green shape equals to the area of quadrilateral ABCO minus the area of sector ABO. We have already found out that the area of sector ABCO equals to 25 times root 3 minus the area of sector ABO. We have already found out that the area of sector ABO equals to 25 pi over 3. Okay, so we actually found out that the area of the green shape equals to 25 times root 3 minus 25 pi over 3 square units. Okay, so that was the second method to find out the area of this green shape. Okay, so in the next step I will present to you a second method to find out the area of the green shape. So we will define the center of the circle as point O. Then we will join together points A and O by a straight line, and also points A, O and B by a straight line. We have already found out that this angle is 90 degrees. I will not return on the same rule. The tangent is always perpendicular to its radius. This R equals to 5, R equals to 5. And we will extend AC. First of all, we will join together points O and C by a straight line. And then we will extend line segment OC until it touches the circle at point H. Point H is the touching point between line segment CO to the circle. Then we will draw a tangent to this circle at point H. We know that the tangent is perpendicular to the radius. That is to say, this angle is 90 degrees, and this angle is also equals to 90 degrees. Then we will extend line segment AC until it intersects with the tangent. At the intersection point between line segment AC and the tangent will be defined as P, and we will do the same thing on the other side. We will extend line segment CB until it touches the circle, and the intersection point between line segment CB and the tangent will be defined as Q. I will prove again that those two triangles can go into each other. Again, in triangle ACO, we will focus on triangle ACO. And triangle BCO. We know that AO equals to BO equals to R equals to 5 units. AO equals to BO. AO equals to BO. We know that AC equals to BC. AC equals to BC according to two tangent theorem. I will not repeat on it. And OC is the common side. OC equals to OC. OC equals to OC. So we proved that triangle ACO is congruent to triangle BCO. Therefore, from the fact that those two triangles congruent to each other, we can conclude that this angle equals to 30 degrees, and this angle is also equals to 30 degrees. I did it in detail in the first method, and when I solved the question in the first method, so I will not repeat it. And we know that angle OCO, OCB equals to 30 degrees. So in triangle HCQ, we know that angle HCQ equals to 30 degrees. This is a right angle. So 90 degrees plus 30 degrees equals to 120 degrees. So we know that the sum of the angles in any triangle equals to 180 degrees. So here we have already 120 degrees, and in order to complete the sum of the angles to 180 degrees, this angle must be equal to 60 degrees. We repeat on the same process on the other side. We know that this angle is equals to 30 degrees, this angle is 90 degrees, so in total they are equal to 120 degrees. So in order to complete the sum of the angles in the right triangle, triangle CHP, to 180 degrees, this angle must be equal also to 60 degrees. Okay? So here, so actually triangle CPQ is an equilateral triangle. So I will repeat again on what I did in the first method, that tangents 30 degrees in triangle ACO equals to AO over AC, and we have already found out we know that AO equals to 5, and we have already found out in the first method that AC equals to 5 times root 3. AC equals to 5 times root 3 in the first method. Here also BC, AC equals to BC, so it is also 5 times root 3. And we have a rule that actually in an equilateral triangle, the center of the equilateral triangle is actually the center of the circle that is enclosed inside the equilateral triangle. That is to say, point O is the center of the equilateral triangle, triangle CPQ. And we have a rule that states that if you, from the center of the equilateral triangle, that is to say from point O, if you draw height to the side of equilateral triangle, then that height will divide the side to 2 equal parts. That is to say, from the center of the equilateral triangle, that is to say point O, we draw the height AO. Therefore, this height divides the side CP to 2 equal parts. So AC equals to PA. So if AC equals to 5 times root 3, then PA will be also equals to 5 times root 3. Okay? And of course, in an equilateral triangle, all the sides are equal to each other. So, and according to the rule that I stated, that is also 5 times root 3, because the height divides the side PQ to 2 equal parts. And this is also 5 times root 3. So, what is the area of equilateral triangle? We know that in any triangle, if the size of this is triangle ABC, the size of AB is A units, the size of AC is B units, and this angle is theta, then the area of triangle ABC equals to A times B times sine theta over 2. Okay? So according to this rule, the area of the equilateral triangle will be equal, first of all, the size of one side of the equilateral triangle equals to 10 times root 3 and all the sides are equal to each other, so it will be equal, the area of the equilateral triangle will be equal to 10 times root 3 times 10 times root 3, that is 10 times root 3 square times sine 60 degrees over 2. Sine 60 degrees is equals to root 3 over 2, and root 3 over 2 over 2 is root 3 over 4. So the area of the equilateral triangle CPQ equals to 10 times root 3 square times root 3 over 4. That is to say, it equals to, here 10 times root 3 square is 300 times root 3 over 4. So the area of triangle CPQ equals to 75 times root 3. Okay? The area of the big triangle CPQ equals to 75 times root 3. And what is the area of the circle? The area of any circle equals to pi times r square. We know that r equals to 5, so it is 5 square is 25 pi. So the area of the circle equals to 25 pi, and actually the area of triangle CPQ minus the area of the circle equals to the area of those three shapes, equals to the area of the green shape plus the area of the yellow shape plus the area of the blue shape. Okay, so the area again, the area of triangle CPQ, the big triangle, minus the area of the circle equals to the area of the green shape plus the area of the yellow shape plus the area of the blue shape. Okay, so we write it down. The area of triangle CPQ minus the area of the circle equals to the area of the green shape plus the area of the yellow shape plus the area of the blue shape. Okay, so we have this formula that the area of triangle CPQ, the big triangle minus the area of the circle, equals to the area of the green shape plus the area of the yellow shape plus the area of the blue shape. Okay, the area of the big triangle minus the area of the circle equals to the area of the green shape plus the area of the yellow shape plus the area of the blue shape. So we will find out those three areas. So it will be equal, so the area of triangle CPQ is 75 times root 3, and the area of the circle is 25 pi. So actually the area of the green shape plus the area of the blue shape plus the area of the yellow shape equals to this expression, but we want to find out only the area of the green shape. But as you can see, the green shape, the yellow shape, and the blue shape are equal to each other in their areas. Why? Because the area is enclosed in a side that equals to 5 times root 3 units in both sides, and the angle between those two sides are equal to 60 degrees, and it is the same about the yellow shape and the same about the blue shape. So they are exactly the same shapes. Therefore, their areas are equal to each other. So in order to find out the area of the green shape, we will divide the total area of those, the green shape plus the yellow shape plus the blue shape. We will divide it by 3, and we will find out the area of the green shape that is actually third. It is third of the areas of the 3 shapes. So we will divide the sum of the areas of the 3 shapes by 3, and that will be the area of the green shape. We divided the areas of those 3 shapes, the yellow shape, the green shape, and the blue shape, by 3 in order to find out the area of the green shape, because the area of the green shape is third of the total areas. So the total area is this expression, and when we divide it by 3, we will get the area of the green shape. That is what we asked to find out. So actually the area of the green shape will be equal to 25 times root 3 minus 25 pi over 3. So we found out that the area of the green shape equals to 25 times root 3 minus 25 pi over 3 square units. Again, the area of the green shape is third of the areas of the three shapes together, so third of the total area is the area of the green shape. Therefore, we divided this expression by 3 and we got the area of the green shape. That is 25 times root 3 minus 25 pi over 3. Okay, so that was the second method to find out the area of this green shape. We will continue and we will find out the area of the green shape in a third method, and we will define again the center of the circle as point O. We'll join together points A and O and B and O. This is the radius that equals to 5 units. We will join together points A and B by a straight line. What is the area of the green shape? The area of the green shape equals to the area of triangle ABC minus the area of circle AB. The area of the white shape. That is circular circuit. Circular circle AB. Again, the area of the green shape equals to the area of triangle ABC minus the area of the circle AB. That is the area of the green of the white shape. Okay, and we know that AC equals to BC according to two tangents theorem. And we know that in front of equal sides there are equal angles, so those two angles are also equal to each other. But here we have angle VCB that equals to 60 degrees, so the sum of those two angles is 120 degrees, because the sum of the angles in any triangle equals to 180 degrees. And they are equal to each other, so if one of them equals to x, then the other also equals to x. So x plus x is 2x, and 2x equals to 120 degrees. And if we divide the equality 2x equals to 120 degrees to 2, we'll get that x equals to 60 degrees. So this angle equals to 60 degrees. This angle also equals to 60 degrees. Therefore, triangle ABC is an equilateral triangle. Okay? And we have already found out that AC equals to, in the previous methods, that AC equals to 5 times root 3. So all the sides of the equilateral triangle, triangle ABC, equals to 5 times root 3. So the area of triangle ABC, according to the formula that I presented to you, will be equal to 5 times root 3. The area of triangle ABC will be equal to 5 times root 3 squared times sine 60 degrees over 2 is root 3 over 4. That is to say, the area of triangle ABC will be equal to 25 times 3 is 75 times root 3 over 4. Okay? Again, the area of triangle ABC equals to 75 times root 3 over 4. Okay? And we must subtract from the area of triangle ABC the area of the circle AB. What is the area of the circle AB? The area of the blue so actually the area of the blue shape, circular circle AB, equals to the area of the sector AOB, the area of sector AOB, minus the area of triangle AOB. I will repeat again, the area of the blue shape, or the area of circular circle AB, equals to the area of sector AB, the area of sector AB, or the area of sector AOB, it equals to the area of sector AOB minus the area of triangle AOB. Okay? Very simple. The area of sector AOB minus the area of triangle AOB will be equal to the blue shape. Very simple. Okay? We have already found out that angle AOB equals to 120 degrees. So, first of all, the area of sector AOB equals to the area of the circle, that is pi times r squared times 120 degrees over 360 degrees. Okay, so that is the area of sector AOB. And what is the area of triangle AOB according to the formula that I gave to you? It equals to 5 times 5 times sine 120 degrees over 2. 5 times 5 times sine 120 degrees over 2. Okay? So here we will get r equals to 5, so r squared is 5 squared, so 5 squared, 25 pi 120 degrees over 360 degrees is 1 over 3 minus, here sine 120 degrees is root 3 sine 120 degrees is root 3 over 2. So it will be 25 times 5 is 25, so root 3 over 2 is root 3 over 4. Okay? So we found out that the area of circular circle AB equals to 25 pi over 3 minus 25 times root 3 over 4. And the area of the green shape equals to the area of triangle ABC, that is actually 75 times root 3 over 4 minus the area of the circle AB. Okay? So it will be equal to the area of triangle ABC, that is 75 times root 3 over 4 minus the area of the circle AB, that equals to 25 pi over 3 minus 25 root 3 over 4. Okay, so the area of the green shape equals to the area of triangle ABC minus the area of the circle AB. That is this expression. So here we will open the brackets and we will get that 75 times root 3 over 4 minus 25 pi over 3 plus minuses plus is plus 25 times root 3 over 4. So actually the area of the green shape will be equal to 75 root 3 over 4 plus 25 root 3 over 4 is 100 root 3 over 4 minus 25 pi over 3. Okay, so the area of the green shape will be equal to 100 over 4 is 25. It equals to 25 root 3 minus 25 pi over 3. Okay, so the area of the green shape equals to 25 times root 3 minus 25 pi over 3 square units. Okay, so that was the first method to find out the area of this green shape. So now I will summarize the lecture. Actually, we found out the area of the green shape in 3 different methods. In the first method, we defined the center of the circle as point O. Then we joined together points A and O and points B and O. AO and BO are the radiuses of the circle that equals to 5 units. It is given us in the question. And we know that AC is tangent to the circle at point A. Therefore, the radius creates 90 degrees with the circle, according to the rule that a tangent to the circle is perpendicular to the radius drawn to its tangency. So this radius is drawn to the tangency point, that is to say to point A. Therefore, this radius is perpendicular to its tangent. That is to say, this angle equals to 90 degrees, and exactly the same thing here. This angle also will be equal to 90 degrees because we have tangent BC that is tangent to the circle at point B, and we have the radius that is drawn to the tangent to the point of tangency. Therefore, the radius is perpendicular to the tangent, that is to say this angle equals to 90 degrees. Okay? And then we joins points O and C together by a straight line, and we know that the sum of the angles inside a quadrilateral equals to 360 degrees. That is to say, angle BOA or AOB plus 90 degrees plus 90 degrees plus 60 degrees must be equal to 360 degrees. And so from this equality we found out that angle AOB equals to 120 degrees. Okay, this angle equals to 120 degrees. Then we proved that AC equals to BC or AC equals to BC according to two tangents theorem. That states that if you have external point of a circle and from a common external point of the circle, that is to say from point P you draw two tangents to the circle, then the length of those two tangents will be equal to each other, that is to say AP equals to BP. So according to this rule, here we have an external point of the circle, that is to say point C, and we have two tangents from point C to the circle, therefore they are equal to each other according to two tangents theorem, that is to say AC equals to BC. Okay, so we focus on triangle AOC and triangle BOC. We know that AO equals to BO, and we also know that AC equals to BC according to two tangents theorem, and OC is the common side, OC equals to OC. Therefore, we actually proved that triangle AOC is congruent to triangle BOC. Those two triangles congruent to each other according to side rule. Therefore, angle OCA equals to angle OCB. Those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. So if this angle is x, then the other angle will be also equal to x. And so the sum of those two angles is x plus x, that is 2x. And 2x must be equal to 60 degrees. We divided this equality by 2 and we got that x equals to 30 degrees. So this angle equals to 30 degrees and this angle BCO also equals to 30 degrees. Then we repeated on the same process here. We know, because of the fact that triangle AOC is congruent to triangle BOC, those two angles are equal to each other. So if we define one angle as y, then the other angle will be also equal to y. So y plus y, that is 2y, must be equal to 120 degrees. We divided this equality by 2 and we got that y equals to 60 degrees. So angle AOC equals to 60 degrees and angle BOC also equals to 60 degrees. Okay, then we focus on triangle ACO, the right triangle, triangle ACO. We know that tangents 30 degrees equals to AO over AC, but we know that AO equals to 5 units and AC is a variable that we want to find out. So tangents 30 degrees equals to A over OC, this is 5 over AC, and the only missing variable here is AC, and we found out that AC equals to 5 times root 3. Okay, then the area of triangle ABC equals to the base of the triangle. The area of this triangle AOC equals to the base of the triangle times the height over 2. That is the formula for the area of any triangle. So the area, the base of triangle AOC is AO and the height is AC. So it is AO times AC over 2. We have already found out, we know that AO equals to 5 and AC equals to 5 times root 3. So we found out that the area of triangle ACO equals to 25 times root 3 over 2. But because of the fact that the triangle ACO is congruent to triangle BCO, they have the same areas also. So the area of the shape ABCO will be equal to 2 times the area of triangle AOC. Okay, so the area of triangle ACO equals to 2 times the area of triangle A, the area of shape ABCO equals to 2 times the area of triangle ACO. But we have already found out that the area of triangle ACO equals to 25 times root 3 over 2. So 2 times that area will be equal to the quadrilateral ABCO. So the area of quadrilateral ABCO equals to 25 times root 3 square units. So we found out the area of quadrilateral ABCO. Then we found the area of sector AOB. The area of sector AOB, this sector, equals to pi times r square, that is the area of the circle, times 100 degrees over 300 degrees. Over 300, the area of triangle, the area of sector AOB equals to pi times r square times 120 degrees over 360 degrees. We know that r equals to 5, so pi r square is 25 pi. So, and 120 degrees over 360 degrees is 1 over 3. So in total we got that the area of sector AOB equals to 25 pi over 3 square units. And what is the area of the green shape? It equals to the area of quadrilateral ABCO minus the area of sector ABO. Very simple. The area of quadrilateral ABCO minus the area of sector ABO equals to the area of the green shape. Okay, the area of quadrilateral ABCO minus the area of sector ABO equals to the area of the green shape. Okay, so we have already found out that the area of quadrilateral ABCO equals to 25 times root 3, and the area of sector ABO equals to 25 pi over 3. So the area of the green shape equals to 25 times root 3 minus 25 pi over 3 square units. Okay, that is the first method to find out the area of the green shape. Then we found out the area of the green shape in a second method. We join together points A and O and B and O, and then we join together points C and O, and then we extended CO until it touches the circle at point H. Then we draw perpendicular to the circle at point H, and we know that radius and tangent are perpendicular to each other. So this is also the radius is perpendicular to its tangent. So this angle equals to 90 degrees, and this angle also equals to 90 degrees. Then we extended CA until it touches the until it intersects with the we extended CA until it intersects with the tangent at point B, and then we extended line 7CB until it intersects with the tangent at point Q. Okay, so then we proved that triangle ACO is congruent to triangle ACO is congruent to triangle BCO. because AO equals to BO, AC equals to BC according to two tangents theorem, and CO equals to CO, so those two triangles can go into each other, so we know that, so those angles are equal to each other. So in total, if this angle equals to 60 degrees, then this angle must be equal to 30 degrees, and this angle also must be equal to 30 degrees. Okay, then in triangle ACO, we know that tangent 30 degrees equals to AO over AC. But we know that AO equals to 5 and AC equals to 5 times root 3. Okay, tangent 30 degrees equals to AO over AC. So in this way we actually found out that AC equals to 5 times root 3. Okay, and after we know that AC equals to 5 times root 3 and AO is the radius that equals to 5 units. We note that the area of this triangle equals to A times B times sinus theta over 2. So actually, if from the center of triangle ABC, triangle CPQ is an equilateral triangle, because actually we proved the triangle CPQ is an equilateral triangle because of the fact that triangle PHC is congruent to triangle QHC. Those two triangles are congruent to each other, so those two angles are equal to 60 degrees. So triangle CPQ is an equilateral triangle, and so the area of the equilateral triangle CPQ equals to, if the side is 10 times root 3, it equals to 10 times root 3 times root 3 over 4. So the area of triangle CPQ equals to 75 times root 3. Okay, that is the area of the big triangle CPQ, and the area of the circle equals to pi r squared, and r equals to 5, so it equals to pi times 5 squared is 25 pi. So the area of triangle CPQ minus the area of the circle equals to the area of the green shape plus the area of the yellow shape plus the area of the blue shape. Okay, but we want to find out only the area of the green shape. But because of the fact that those three areas are equal to each other, we divided the outcome from the, after we subtracted the area of triangle ABC, after we subtracted the area of triangle CPQ from the area of the circle, we got those three areas. And after we divided it by 3, we got the area of the green circle, because the areas of those, the area of the green shape and the area of the yellow shape and the area of the blue shape are equal to each other. So if we have the total areas of the free shapes. We divided it by 3 and we got the area of the green shape, because the area of the green shape is third of the areas of the free shapes together. Okay? Again, the area of triangle CPQ minus the area of the circle equals to the areas of those free shapes. So we divided the area of the free shapes by 3, and that is the area of the green shape, because the area of the green shape is third of the area of the free shapes together. Okay, the area of the green shape plus the area of the yellow shape plus the area of the green shape divided by 3 will give us the area of the green shape, because the areas are equal to each other. So the area of the green shape is third of the area of the free shapes together. So we divided the total areas of the free shapes by 3, and we got the area of the green shape, that is 25 times root 3 minus 25 pi over 3 square units. Okay, so that was the second method to find out the area of the green shape. Then we found the area of the green shape in a third method. Actually, the area of the green shape equals to the area of triangle ABC minus the area of the blue shape. Again, the area of triangle ABC minus the area of the blue shape equals to the area of the green shape. Okay, the area of triangle ABC minus the area of the blue shape equals to the area of the green shape. Okay, but we know that the area that triangle ABC is an equilateral triangle, so the area of triangle ABC equals to the square of one side times root 3 over 4. That is to say, the area of triangle ABC equals to 75 times root 3 over 4. That is the area of triangle ABC. Then we calculated the area of the green shape, the area of the blue shape. That is the circle AB. So the area of the blue shape equals to the area of sector AOB minus the area of triangle AOB. Okay, the area of the blue shape equals to the area of sector AOB minus the area of triangle AOB. Okay, and what is the area of sector AOB? The area of sector AOB equals to the area of the circle times 120 degrees over 360 degrees, and the area of triangle AOB equals to 5 times 5 times sinus 120 degrees over 2. Okay, so we found out that the area of the blue shape equals to 25 pi over 3 minus 25 root 3 over 4. Again, and the area of the green shape equals to the area of triangle ABC, that is 75 times root 3 over 4, minus the area of the blue shape, that is this expression. Okay, so we found out that the area of the green shape in the first time equals to 25 times root 3 minus 25 pi over 3 square units. Okay, thank you very much.